Consider a finite wing with an aspect ratio of 8 and a taper ratio of 0.8. The airfoil section is thin and symmetric, and with this in mind, we must calculate the lift and induced drag coefficients for a wing when it is at an angle of attack of 5 degrees. Now, we can assume that delta is equal to tau, where delta and tau are the induced factors of drag and lift, respectively. So we first start off by finding our factor of delta. So we're given that we have a taper ratio of 0.8, so we can draw a line essentially going from 0.8, and then we have an aspect ratio of 8, so essentially be along this line here. So essentially take the intersection and then draw a horizontal line across to find our delta value. So we can say from the graph, delta is approximately 0.055. So now the next step is we can solve for the lift curve slope, because now we have all of the components. So we have A is equal to A naught divided by 1 plus A naught divided by pi times aspect ratio, and in parentheses 1 plus tau. But in this case, we said tau is equal to delta, so we can just interchange the values. So now we can plug in all of the values. So A naught is going to be equal to 2 pi, and this is going to be in radians. And then we'll have 1 plus 2 pi divided by pi times aspect ratio, which is 8, and then 1 plus our tau value, which is equal to delta. So 1 plus 0.055. So this gives an A value equal to 4.97 radians, or per radian. And we can convert this by multiplying by 180 degrees divided by pi to get 0.0867 per degree. So one thing that we should note is since the airfoil is symmetric, so then our alpha at lift is equal to 0. That's going to be equal to 0 degrees. Now this will be important for when we calculate the coefficient of lift, because coefficient of lift is equal to our lift curve slope, A, times our angle of attack plus the angle of attack where lift is equal to 0. So in this case, that will be 0. So we're just left with A times alpha. So we'll have 0.0867 per degree, and then we'll multiply by the angle of attack, which was 5. So that'll give a coefficient of lift equal to 0.4335. Okay, so for the last part, so we have the coefficient of drag induced. That is going to be equal to the coefficient of lift squared divided by pi times the aspect ratio times 1 plus delta. And then in this case, we do have all values, so we can just plug and check. And that leaves us with a coefficient of drag induced of 0.00789.